So our experiment is experiment 9, the ideal gas law. And what we'll be doing is using a reaction of magnesium and hydrochloric acid to produce hydrogen gas. And we're going to collect that in what's called a eudiometer. A eudiometer is basically a graduated cylinder for collecting gas. So it's basically an upside down tube, and I'll show you this in more detail in a second. And we'll carry out the reaction actually in the bottom portion of the eudiometer. That'll create the gas that gets trapped in the tube, and then we can measure the volume of the gas. What we're going to be able to do is compare the yield that we get of hydrogen gas to the actual yield of hydrogen gas in the eudiometer and calculate a percent yield for the reaction. So our first step then is to measure the magnesium strip. So I've tared out the balance and I have my magnesium strip, so I'll go ahead and place that on there, and you should write those digits down. The place to write this down is for trial 1 on the last page of the report sheets. One other thing that you'll need to know for these next 2 trials is the barometric pressure. And I asked Siri actually what the barometric pressure was in Readly, and it's 29.86 inches of mercury. And you'll have to convert that into millimeters so that you can use it with this experiment, and eventually you'll convert that to atmospheres to use with the ideal gas law. The current room temperature is 30 degrees Fahrenheit. So it's not the standard 25 degrees Fahrenheit. And so you'll need to use that in your calculations as well. I have all the things laid out for what I'll be doing in this next step, and I thought I'd just say something about this. If you want to be efficient in a laboratory or any workspace really, it's important to read the instructions of what you're doing and make sure that you have everything prepared ahead of time. I am actually modifying the procedure a little bit from the original procedure, but I think I'll rewrite it for you guys. There's the magnesium strip. Here's a piece of copper wire, parafilm, the hydrochloric acid that I'll need, the water, and the pipette that they say that you need. And you don't really need it, but it makes it much more convenient to dispense the hydrochloric acid from a pipette. And so next what we'll do is we'll prepare the magnesium to be used in this experiment with the copper wire. Okay, so in this experiment, this piece of magnesium is going to react with hydrochloric acid in the end of the eudiometer, and it has this tendency to float away. So what we're going to do is create a cage for it to kind of hold it in place. So to do that really basically is pretty simple. You pinch it in place. So I'm going to do this, all right, and then I'm going to wrap the wire around it like this. And it doesn't have to be like precise. The idea is that you surround the piece of magnesium with copper so it doesn't float away. You don't want to make it too tight, but because you need to let the hydrochloric acid react with it. But you also have to make sure it sort of stays in the tube. The other thing that I'm going to do is I'm going to put a little kink in here, because in the tube you don't want this copper wire to fall out. So there needs to be a little bit of pressure of the copper wire inside the tube to hold it in place. And something like that will typically work. Okay, so we'll go ahead and test it out and see how it works. Let me grab the eudiometer real quick. So here's the opening. Move some stuff out of the way. And make sure it goes in, and see how it presses on one side, and then when it goes in, it'll press on the other side as well. So it's kind of tight, and that'll hold it in place. Okay. So what I need to do next is go ahead and fill this up with hydrochloric acid and water. So here we go. This is the hydrochloric acid. I'm going to go ahead and add that in. Now, hydrochloric acid, this is 6 molar, is more dense than water. So I'm adding it right now. It's at the bottom of the tube, but when we use the tube, I'm going to flip it over. Okay, so, and then I'm going to add this water slowly because I don't want a lot of mixing to take place. Now, once I've added about 4 or 5 mils of water, that will insulate the rest of the hydrochloric acid from like turbulence created by the water coming in, and I can add the rest a little faster. So what's at the top of this tube is essentially pure water, but what's at the bottom of this tube is hydrochloric acid. So now what I'm going to do is I'm going to take my copper wire and I'm going to insert it like this. And it's a tight fit, kind of pokey, like that. You can always pull it out with forceps when you need to. I'm going to top that off just a little bit. And I'm going to put a little parafilm is what this is called on the end. Now I'm not going to completely cover the end. The idea is to be able to let liquid out, but you want to kind of trap the hydrochloric acid in there a little bit. So what I've done is I've put it on so that there's a little bit of an opening on this side here, okay? So now this is ready to go. Okay, so I keep my finger on here because there's a hole. I'll put it in the water and I'll flip it over like that. And I'll make sure that this goes all the way to the bottom for now. So you can see there, I'm going to move this beaker so you can see this better. So again, there's the magnesium right there. Right about well, I guess that's what the 300 mil mark on the beaker, about 250. So right now, going up the side of the eudiometer here, what I'm looking at, all right, and you don't see anything. It's full all the way to the top with liquid. All right, the hydrochloric acid is slowly drifting down. Now you can't see it. It has a little bit of color, but normally you don't get to see that. And now you can see there's bubbles coming up, right? That's because the hydrochloric acid has made its way down to the magnesium. Let me get a clear spot. Here we go. Just like that. Now, once the hydrochloric acid eventually drifts down to the bottom, it'll begin to react fairly rapidly, but it does take time. So I'm going to go ahead and put it on a time lapse. So we're getting close to the end. You can see, maybe you can see, gas is getting formed at a fairly rapid rate from the magnesium now. You do potentially get loss if this piece of parafilm isn't on the bottom and it's not pressed to the bottom. A lot of times the liquid, well, as it comes out, because the gas is being formed, a lot of those bubbles get lost, but this looks like it's trapped it pretty well. A little bit more to go, I think. Well, hopefully it all fits in the tube. We'll see. So pause, we'll come back when this is all done. Oh, you see how the magnesium got away? Hopefully that doesn't affect us too much. It probably is paper thin at this point. Well, that's gonna kind of a bummer. That is part of the experiment, so hopefully we can capture all that. We'll come back here in a minute or two and take a look at it. So it looks like it did all react. Now our next job is to try to get a measurement of how much gas there is. Now you'll notice the very bottom says 50, and then it says 49. And so that line that we see right sort of towards the middle of the screen here, that's actually 48. You can kind of see the 48. So we're going to make the camera at the same level as the liquid. And try to measure that meniscus. Okay, so in doing that, though, you have to be careful in the way you're reading it. And remember, this just says 49. So you could do a 49 point something, but you can really estimate in between the tenths. And so you should be reading this value to the hundredths. All right, so this is for trial 2 of experiment 9. I'll go ahead and put my piece of magnesium in there. That's the mass. You can actually see the hydrochloric acid sort of slowly moving down. Happens in this experiment sometimes, and you can see there's a pretty good sized chunk of magnesium up here. If you wiggle it, you can get it to react faster. So I'm going to spend a little time doing that, and hopefully it will all react away. See that? Okay. So there you have it. That's again, that's the 49 mark. So the 48 mark is up there, so it's very close to about 49 and a half. So it's just a little bit more than 49 and a half. I'm just telling you because there's not a good reference that you can see in the video. Like the 48 is kind of obscured by the meniscus in the beaker. The other thing I think I'd like you to notice is how it looks pink. And again, you'll learn this trick later in the semester. I'm just holding a piece of pink and white paper down below, and what that's doing is sort of reflecting or diffracting off of the meniscus inside the eudiometer. And you can see the actual volume a little bit better that way. It's kind of a standard trick. Okay, so there you go. So that's the data you need for trial 2. Use the same temperature and barometric pressure. I just checked, and they are the same as it was before. It's still pretty warm in here, but it's not too bad. So there you go.